7th grade math, 25 study guide, problem number 1. It says George uses 2 1/4 cups of flour for every 1/4 cup of sugar for a recipe. If you wanted to use this recipe but make more, that means proportional, what would the number of cups of flour he should use? What would be the number of cups of flour he should use for every 1 cup of sugar? So since they said sugar second, we're going to put sugar on the bottom. And if we want to know how much of these per one of these, that's unit rate. We always just divide top by bottom to get unit rate. So I got top divided by bottom, which means multiply by reciprocal, but I have to convert mixed number into a fraction by starting at the bottom, multiplying 4 times 2 and then adding 1 to get 9, keeping the same denominator, crossing out my 1's and I see that's 9. That means if it's 2 1/4 cups of flour for every 1/4 cup of sugar, that would be 9 cups of flour for every 1 cup of sugar. Problem number 2 says the table shows a proportional relationship between the grams of granola and the grams of chocolate. So since they said chocolate second, I'm going to put chocolate on the bottom. So I'm going to take one of these coordinates, 2, 4, and put 2 over 4 and I get 3 grams. What that means is there's going to be 3 grams of granola for every 1 or each gram of chocolate because I put chocolate on the bottom. Alright, number 3. Which expression below is equivalent? We're going to pick all that applies. So we take the first expression they give us, 3x plus 7x minus 2x minus 7. I can do my rule for subtraction, draw 2 sticks, add the opposite, combine my like terms. 3x plus 7x is 10x. Take away 2 of those x's is 8x. 9 and 7 negatives is 2 positives. So I got 8x plus 2, which is expression 1. It is not expression 2. For expression 3, I have to simplify that first. So I go 10x, take away 2 x's is 8x plus 2. That's the same. And expression 3 would be 8x plus 16. That's not the same. So my answer is expressions 1 and 3 are equivalent. Okay, so we're looking at problem number 4. In problem number 4, it says find the value of 8 times the quantity 8.5 minus 3.5. Well, I could distribute here, but since these are like terms, they're both constants, right? Numbers with no letters, I'm just going to subtract them. 8.5 minus 3.5 is 5. 8 times 5 is 40. Number 5, Jane has $14 and earns $11 an hour for babysitting. She wants to buy a $175 item. Well, the money that she earns, that she has, or the $14 plus the $11 she earns per hour, has to be greater than or equal to what she wants to spend. So that's why the math is going this way. So to solve this, I work farthest away from the variable first, do an inverse operation. The opposite of positive 14 is to subtract 14. That makes that go away here. But now I have to take away 14 from 175. I want to know what x is because x's are my answers. My answers are going to be more or the same as whatever I get. So I divide both sides by 11. And I show the division over here. As I'm dividing this, I'm getting 14 point something. But we can actually stop there. Because at this point, we're not supposed to be using calculators, right? We're supposed to do this just manually. But if it's 14 point something and it has to be more than 14 and it's the least number of whole hours, like you're not going to go and say, I'm only working for 1/10 of an hour today because that's all the money I need. No, you're just going to work a whole hour or not. So no matter what this is, I have to round up because it has to be greater than 14, and the nearest whole hour greater than 14 is 15 hours. So that's why I stopped early on that one. Number 6 is an item has 7% sales tax. The original price is $400. What's the amount you're going to pay with tax? So we can find 7% of 400 using the percent proportion like we've been doing all year, right? Cross, multiply, and divide. But at the end, you have to add that tax onto the original 400 and you get the price with tax. But you know what? Those of you who like to take shortcuts, if you have a nice number like 400 and 1% of something is just moving the decimal 2 times. 10% is moving 1 time, 1% is 2 times. So 1% of 400 is $4. So if I wanted 7%, that's $4 times 7. Or I would just add 28 onto 400. So if that makes sense, use a shortcut. Otherwise, this way always works when it's not nice and easy like that. So for number 7, it says Caleb poured 1/4 of the water, so 1/4 of. Remember, 1/4 of means 1/4 times, right? So 1/4 of her water, she had 2 liters. How much is left? So we got to find 1/4 of 2 liters. 1/4 of 2 liters means 1/4 times 2 liters. So 1/4 times 2 liters, I take the 2 and I write it as a fraction. I do my factor trees and cross out my 1s. And I have 1/2. Now that's not our answer. Be careful. That's just 1/4 of 2 liters, or half a half liter. 1/4 of 2 liters is 1/2 liter. So I did 1/4 times 2. I got 1/4 of that, which is half of a liter. Now that's spilled out. So now you have to subtract 1/2 from 2, and you see that your answer is 1.5 liters are left. So for number 8, we're going to find the scale factor, right? We have two triangles that are drawn to scale, or they're proportional to each other. They're similar shapes. And so what I do is, if it's going from A to B, then what I do to get the scale factor is I take two corresponding sides in the same spot, right, wherever they're at in the same spot, and I put the new one over the old one. And sometimes it's a smaller number, a fraction. Sometimes it's bigger, like if the image got bigger, then it should be bigger than 1. So I just put new over old, and that's it. If I do that with 26 over 13 or 24 over 12, you're going to get 2 every time. That's the scale factors 2. Number 9, an object is a scale drawing, and it's 4.6 inches tall. The scale is 1 inch to 10 feet, so every 1 inch is 10 feet. So if you got 4.6 inches, just multiply it by 10, right? Now, if it said the scale was 2.5 inches to 10 feet, then I would write a proportion. But if it's just 1, 2, whatever, just multiply. Multiplying by 10 is easy, right? Just move the decimal 1 time. Okay, so for 10, we have 2 circles. One has a diameter of 4. What are the units here? 4 feet. So if it's 4, then the radius is 2, right? Radius is half diameter. So I can find the area for that circle by doing pi r squared. Pi is about 3.14. Our radius is 2. Remember to do the exponent first. Do 2 times 2 before you multiply by 3.14. You should get the correct area of 12 and 56/100 feet squared. The second circle had a diameter of 10, which means the radius is 5, half of that, right? So we use the radius in the formula for the area of a circle. And we have to do your exponents before you multiply. Order of operations, right? 25 times 3.14, you should get 78 and 5/100. And they're asking how much bigger is one than the other, so I take the big one, I subtract the small one, and I get 65 and 9400 square feet, or feet squared is the same thing. Okay, so we are now on, looks like number 11. And so number 11, they give us a circle. And for 11, they start out by giving us the circumference of that circle first. So they say the circumference is 10 and 2500 centimeters. So we're going to use a circumference formula. Circumference is 2 pi r, not to be confused with pi r squared, because 2r is not the same as r squared, right? R squared is r times r, not 2 times r. So I take the circumference that they give me, 10.25. I always use 2 per the formula, and I always round pi to 3.14. So now when I multiply 2 times pi, that's 6.28. Good idea to memorize that, right? Because we use that so much. If I want radius, I divide both sides. In other words, I isolate the variable to see what the variable equals. And my hints on the test tell you just round that to 2 decimal spaces. So I look to the right. Since that's not 5 or bigger, it just rounds down to 1.63 as opposed to rounding up to 1.64. So now I have my radius. I can find the area of the circle. The area of the whole circle would be pi r squared. So the r is 1.63. So in my calculator, I go 1.63 times 1.63. You should be doing this with me right now on your calculator. Times 3.14, and you should get an area of about 8 and 3400 with some change. Now, just leave that in your calculator, because the question isn't done yet. They're saying that this circle, they're having you kind of imagine there's a drawing. They're saying there's a circle with 1/4 of the circle shaded. What's the area of the shaded region? In other words, you have to find 1/4 of this number. So 1/4 of means 1/4 times. So again, we're just going to multiply this by 1 and divide by 4. But since it's 1, we just divide by 4 on a calculator. And the directions say round to the nearest whole number. So it's about 2 centimeters squared. So problem number 2. Okay, I drew up this shape right here for you, number 2. And I wanted you to find the area, right? So it looks like this at first. Okay, so what we do then is we take a look and we see we divide this up into different shapes. I got a triangle and 2 rectangles. So the big triangle is 9 by, if I add 9 plus 3 plus 9, that's the same as this, or from here to here is 21. So 9 times 21 is 189 square units. This little one is 3 by 3, that's 9. 3 times 3 is 9. Over here, this is 9 square units, but I have to find this. 9 times 3 is 9. 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 9 times 3 Okay, don't be confused. That's number 12. It's not 12 units long, okay? So I got to find this. So it's 30 all the way. From here to here is 21. So if I subtract those two, that's what's left, that height. So I get that height right there. 21, 30 take away 21, so that would be 9 units. So I got the area of this triangle is 9 times 9, which is 81, but it's a triangle, so we divide by 2 at the end. So I got half of that. I got 40.5. I add these three up, and I get my answer. 238 and 5/100 is the area of that figure there. So, number 13, we're talking about volume now. We have a rectangular prism here. And I said that the box fell sideways like this in the problem, okay? Because some of you think that the base has to be on the bottom all the time. It doesn't. The base can be sideways here, so that's why I told you it fell sideways. So we have a rectangle, and it says that this height of the base, this is the base down here, the colored part, the height of that, not the height of the whole thing, because remember it's sideways, is 12. And then they say that this perimeter for this shaded area here is 52. So perimeter is this plus this plus this plus this, or the distance all the way around. So I have 2 lengths and 2 widths of that rectangle on the bottom. So 2 lengths is 2L, 2 times L, plus 2 width is 2W. So I just plug in the formula. The perimeter is 52. I'm trying to find the width because I need that to get the volume later. I have 12 and another 12 over here, 2 12s. 2 times 12 is 24. If I want to know the width, or if I want to find W, I solve this equation. I isolate the variable. Work farthest away from the variable first. Divide by 2. The width is 14. So I know now this is 14 units. So this is where I'm at now. Okay. The problem says this length of the whole thing, which is kind of like the height of it actually, because it fell down. So that length is actually the height of the whole prism. So this length down here is 3 times this width that we found. So I multiply that by 3. And I get this measurement down here, and now I have a 12 by 14 by 42. The volume is, just multiply all those 3 of those together in your calculator. That's how you find volume. 42 times 14 times 12. Type that in, and it's inches cubed. Remember, for volume, it's cubed units. It is not square units. That's area. Okay, so 14, it says a large box has a height of 24 inches, a width of 16, and a length of 16. Then they give us the dimensions for a smaller box. They ask us how many smaller boxes can go into the large box. We got to find the volume for the large box first. So I just take those dimensions and I multiply all those in my calculator. I do the same thing for the small one. I multiply the dimensions they give me for the small box. And then I just take those two numbers and divide them. Now, if you're a tutor or a parent and you're saying, yeah, but the dimensions have to fit just right, or even though the volume will work, it might stick outside, I make sure to use dimensions that work so they don't have to worry about that. Okay? All you're doing is finding 2 volumes and dividing. So 48 of those little boxes will fit into one of those big boxes. Number 15, Joe is using a shovel to fill a hole with dirt. Every time he scoops, the amount of volume is the same as a box that has those dimensions. 3 inches by 6 inches by 2.5. That's the amount of dirt he scoops each time. So, if we're a rectangular prism with those dimensions, I would just multiply those 3 to get the volume. So we know that every scoop has 45 inches cubed of dirt. The hole he has to fill, well, it's a hole, so it's kind of difficult. It's not perfect, but the amount of volume in there is equivalent to a rectangular prism with these dimensions. And so I just multiply those to get that volume. And the question is, how many scoops can go in there so that this is at least 80% full? So I want to find the minimum amount to make this 80% full. So what I do then, I have to find 80% of the total volume of the hole. 80% of, I can use my percent proportion. Or, since we're using calculators, 80% is just 0.8. So I do 0.8 times 6,720. So do that in calculator. Do 0.8 times 6,720, and you got that number. This is the volume of the hole if it were filled 80%. So how many times does 45 go into that? I just divide these two. Now, this would round down to 119, right? But we have to say at least 80% full. So and this is a situation we always have to round up. So because it's at least, so it's 120 scoops. 16. At lunch, they're giving away T-shirts 5 are small, 40 medium, 2 large, 3 extra. If you caught a shirt, what's the likelihood of you catching medium? Well, the total sample space is, we add all those up, right? Add all the shirt sizes. There's 50 shirts total that are going to be thrown. Okay. The expected probability of catching a medium, well, there's 40 mediums. So 40 out of 50 is 45, or 80%. That's what we call likely. So just some review. If there's no chance of it happening, then it's impossible. If it's less than 50% but not impossible, it's unlikely. If it's 50% right in the middle, it's as likely as not. And if it's more than 50% but not 100%, it's likely. And if it's 100%, it's certain. So we need to memorize those likelihood terms. Okay, so number 17, we have a table here. And it says, this is our sample space, right? We had some experimental probability here. And the number of times we got yellow, red, and green are in the table all together. If you add all those up, which you have to do for these problems, there's 100 total drawings there, or spins, I should say, sorry. So the question says this: based on these results, give the number of times the arrow should land on green out of 30 times. Okay, so it's green 27 because of our table, right? Out of 100, I add those up. If it's 27 out of 100, how many would it be out of 30? So, where am I at here? Here's my number 17. So if it's 27 out of 100, how many would it be at if the total was 30? I put total on the bottom, total on the bottom. This is another proportion problem. Cross multiply. Dividing by 100 means move the decimal 2 times. Don't even need to get our calculator for that part. 8.1. Now, this is not one of those questions that says what's the minimum amount of time to get at least. So we would just round mathematically. 8.1 will round down to 8, so it's about 8 times. Number 18 says, a coin is flipped 2 times. Find the probability of coin landing on heads both times. Well, if you flip it once, the probability is 1 out of 2, right? Because there's one side that has heads and out of 2 total sides. The second time is also 1 out of 2. Now, if you want to do it together, first one and then the other, you got to multiply those probabilities. So the probability is 25%, or 1/4, or unlikely. So number 19, it says John performed an experiment. He picked out of a bag 100 times. And so we had these colored marbles. And we had to say which one of these is true. Now, the first thing that he noticed from his experiment's probability, or his observed frequency, is that there was about 3 times as many blue as green marbles. So I'm going to go through here and figure out which one of these has about 3 times as many blue as green. So A has, look at blue and green. Blue and green, that does not have about 3 times as many, so don't pick A. B, blue and green, that does not have about 3 times as many. It can't be B. C, that has exactly 3 times as many. It might be C. D, 30 blue, 10 green, that's 3 times as many, so it could be D. So it could be C or D. Next, it says purple about 1/4 of the time. So if it's only possible that it's C or D, I just look at C or D again. Look at purple. 10 out of 100 is not 1/4. 24 out of 100 is about 1/4, exactly, but close enough, so the answer has to be D. Last problem, number 20, says we have a table again, and it says we did a sample of students at TMS. And if you add all those up, you can see that it was 50 students, right? So out of 50 students, we have this information. This is our observed frequencies. And then we got to start answering these questions. Number 1 says, first statement says, is it true that 1% of the students preferred Facebook? Well, one student preferred Facebook, so it's tempting to say yes, but if you add those up, unless it adds up to 100, that's not 1%. It actually adds up to 50. So 1 out of 50 is not 1%, it's 2%. Statement 2. It says out of 200 students, it's expected that 80 would prefer Snapchat. Well, according to the table, 20 out of 50 prefer Snapchat. So if 20 out of 50 prefer Snapchat, is it true that 80 out of 200 would prefer Snapchat? So in other words, is this proportional to this? So I write a proportion and check. So I can cross multiply and see if I get the same thing. Or if you see this is 4 times bigger, this has to be exactly 4 times bigger as well. If it is, then that's a true statement. They are proportional, it's a true statement. Next one. So statement 3 says this. Statement 3 says there are 8 times as many students who prefer Twitter over Facebook. Well, 8 people prefer Twitter. Only 1 prefers Facebook. 1 times 8 is 8, so yeah, that's true. Statement 4 says this. For every 40 students, 41 prefer Instagram. Okay, so now on the table, we see that 20 prefer Snapchat, 21 Instagram. So that's our ratio of Snapchat to Instagram. So the question is it true that 40 students would prefer out of 41 Instagram? So I set up a proportion again, just like I did the other one. I cross-multiply to see if I get the same thing. I see they're not. Or if I just multiplied by 20, I wouldn't multiply exactly by 20 to get this. So that doesn't work either way. So that's not the same. So we know our answer for that has to be statements 2 and 3. All right, 7th grade. I hope that helped you out.